BYU-Idaho 58.4 kilograms. Okay. 10.4 how many kilograms of violet? Okay. So
Oh wow. So you have to do 3 limiting reactants. So 10.5 kilograms of this. And 58.4 and 58.4. Yeah, wow. Okay.
I know, right? I'm like, this seems like overkill for
They
Chem
want to
105.
drill this into.
Yeah.
But it's not that bad.
Okay. So yeah, 25 grams of that. Oh, kilograms.
We could just change everything to grams if you want,
Yeah, probably
because
easier.
it'll give us the same answer.
So, when we just bump the decimal over?
No, don't even worry about the decimal. Just pretend that they gave us all those units in grams, and and then at the end, just call your answer kilograms.
Wait a minute. How's that going to work with the math, though?
Well, it won't, but it'll save us time. We can do this. So grams, we could bump that over. If that was kilograms, then it would bump over 3 places. So grams and grams and grams.
Okay, so we need to figure out for each one. Okay, so we have to find the limiting reactant.
Yep.
I went back to my notes and I don't really have any on that.
Yeah.
I did like one problem.
I'll show you what I think is the easiest way to do it. There's a couple different methods. You could do like a ratio, set it up, find out which one's limiting reaction. But what I like to do is just go from, so do 3 different equations. So you'll start with 10 grams Al2O3 and get it to moles, and then use the molar ratio to get it to moles of this. So let me just put units. So we're grams to mole, and then we'll do mole Al2O3 to mole Na3 AlF6. And then that will give us an answer in moles of this. And then we do that same thing for this guy, 400 grams NaOH. And so what this will do is it'll tell us how many moles of product will be formed. And one of these will form the littlest amount, and whatever forms the smallest amount of product, that's the limiting reactant, and that's how many will be produced.
Okay, hold on.
Yeah, we'll go over that.
Okay, so you said the answer, because in my mind I was thinking like never mind, I don't know what I was thinking. So, the answer, oh, okay, because it's Na3ALF, so that's how much we'll produce of that.
Mm-hmm.
And the smallest one is the limiting reactant, that's how much you can, that makes sense.
Yeah, okay.
So from there, so that's the answer then?
Yeah,
Just the smallest one?
Yeah, that would give us moles though, so then we just need to go from
Right.
moles to kilograms, moles to grams, and then times divided by 1,000.
Okay. And then, what's kilograms?
Yeah.
Okay.
And then the two, because like,
So
let's...
the other two that aren't limiting will be the excess ones.
Yeah.
Excess, okay.
Let me just put in some hypothetical numbers. Let's say this was the limiting react. Oh, it tells you actually. It says that AlO3, this is the limiting reactant. So let's say that you got 4 moles. This one you get 6 moles, and this one you get 8 moles when you do the calculations out. So limiting reactant is the lowest. So you actually produce 4 moles of this, which when you convert it back to kilograms, let's say it's 43.2. So now you need to know how much of these two remain.
So, okay, so you have to convert all of them back to kilograms.
Yeah, and this is the tricky part, because
if there's not actually 6 left over, there's 2 and 4 left over.
yeah.
So you just would, instead of 6 moles or whatever that is, you do 2 and convert that into kilograms?
No. No, see, and that's the part that's tricky, because what you have to do is you can only produce 4 moles of it. So you have to plug in 4 moles, do a whole nother equation. So you have 4 moles, and now this is your product, Na3AlF6. And you have to use these same equations but backwards to see how much was required of each to produce that 4 moles.
Oh, what the heck?
Yeah. So then let me just write units. So moles Na, so the moles will go on bottom, grams, you'll do the molar mass. Or no, not yet. You'll do molar equation. So mole Na3 ... to NaOH. That cancels with that. And then you'll do mole NaOH to grams. And same thing with this guy. Start with 4 moles of Na3AlF6. Do its mole ratio. So mole Na3 to mole HF. Then it's grams per mole HF. And there's still another step after this. So you'll find that this will equal somewhere in the neighborhood of like 280 grams, and this one would be like somewhere around that same neighborhood, 290 grams. And so that's how much was used up to make your product.
And then you have to subtract it
from what you originally had, and that will give you what's left. So then the last step is to take your 58,400 minus 2,800,000 equals X grams remaining of NaOH and and same thing for HF. So that's probably the hardest part, because lots of people, they'll do this and say, okay, well, you know, we have 2 moles of this left over and 4 moles of this left over, and so they'll just convert that to grams, when really you can't do that, because you have to take it back from the beginning and find out how much was used up.